Good afternoon, and welcome to this learning experience titled Innovation, Influence, and Originality. I'm Augustus Wendell, and I'm an assistant professor of the practice here at Duke University in the Department of Art History, and Visual Studies. I'm also core faculty in the Computational Media, Arts, and Culture group. And our workshop today is in support of the AI for Art Competition 2022. So you may have attended or seen our learning experience from last week where we had a roundtable of faculty, staff, and a PhD student where we spoke about generative systems, artificial intelligence, artwork, and how to look for opportunities therein, all in an effort to kind of build some structure and support around students who perhaps are familiar more with technology or less with artwork. And today's learning experience is specifically tuned to students who have an interest or a background in the visual arts, but perhaps not the technology. So I'm going to first talk about some general approaches to visuality in artwork, which will be a little narrow band of discussion, but try to bring up some points that hopefully should resonate through the talk today and through the work today. And then we'll briefly discuss how we could define AI and maybe break through some constructs we have that presuppose what AI is, especially in terms of the creative workflow. And then the bulk of the afternoon will be looking at methods to make, implement, use artificial intelligence, and that's going to break down into four categories where we'll look at generative. Maybe drawing isn't quite the right term here, but generative construction, generative programmed computational artwork, where we're more directly telling the system what to do. We'll look at something called pix-to-pix, which is a kind of neural network machine learning approach to creating and synthesizing images. We'll look at GANs very briefly, which is another neural network approach. And then ultimately, we're going to conclude with looking at style transfer, which is a very arguably cliche from when it was first introduced, but still very powerful system for being able to implement some neural networks involved in creation of visual assets, visual media, visual artwork. So that's the trajectory. And if you have any comments today, I have a window open where I can see them. So feel free to be asking questions along the way, making comments if you have some. So let's look at approaches to visuality and artwork. And some of these slides came from the talk last week and are informed by the same topics that came up along the way. And what we're looking at here is an Andy Warhol print of Marilyn Monroe. And we had Bill Fick was one of our guests in the previous talk, who's a master printmaker. And I think much of what came out of that was thinking that this image may feel non-technological to us, non-computational to us, but the screen printing, the very process of taking an image, in this case of someone very important from popular culture or someone who is in the limelight in media, in popular culture, taking an image of her and then passing it through the lens of a technology, in this case, a screen printing mechanism and kind of everything that surrounds that, and creating iterations and versions of her picture with coloration is absolutely a technological process, and yet also elevating her image to art and to high art. So I think within this image, there's so much for us to think about in terms of if we're using imagery, where is it coming from? What's the critique that we're providing by choosing that image? What we're doing to it? Are we coloring it? Are we passing it through technology? So this image encapsulates quite a few trajectories that we'll be passing through our work. This is an image of Richard Serra, a sculptor, who was, in this case, throwing molten lead. So in his hand, he has a metal kind of ladle, if you will, but of large scale. And he is hurling molten lead. And the results of that were these casts of junctions of walls and ceilings. So how far we come from Marilyn, and yet we're still ostensibly in the realm of art. In this case, we're in the realm of sculpture. But instead of picking an image from culture, this is about looking for opportunities to assess the world around, right? To look at things that are not precious, just a floor and a wall and some lead, but turning it into an artwork that is one of a kind and that's precious. So interesting choices about selectively choosing some starting point that is not from pop culture, but maybe very personal to the artist. This is a data postcard from a project called Dear Data, where two data scientists sent back and forth to each other these postcards. And this is data-driven, encoded information using symbology and color. And the backside is an explanation of how to read it. So in this case, could we call this artwork? I think we could. This is intriguing and beautiful and encoding life and embodied kind of experience in the world, and is doing that computationally, not through a technical computer process, but through encoding, right? What's the color? What's the shape? What do they mean? How do you unpack this? And if you're interested in this project, I suggest you look it up. There was a lovely book made, and I think they did it every week. So they had 52 different exchanges of postcards thematically encoded. This is a Saul LeWitt line drawing instruction. So Saul LeWitt made not per se the drawings, but a way to draw, a set of rules. And this also came up in our last talk about how algorithms and rules are one and the same, and that some system like this that says, here's how you draw this thing that I want, is entirely an algorithm, and that the outcome, something along these lines. This is a different wall drawing of Saul LeWitt's, but it is a set of lines that were made in space in a site-specific location, and it is not figural like Marilyn, but it is a transcription of process, of the people that made it, of the system that made it, of the rules itself, and instantiation of an algorithm in a visual environment. This is a project, I believe, by Golan Levin, where there is a sensor, a camera that is picking up the user's faces. This is in a gallery. And then on the screen, it's remixing those faces. So it's taking not a precious image, but a very personal image, and then synthesizing new approaches to the way we understand people, humanity, participants, adjacency within space through remixing of images. So then maybe we can look at some imagery that we might consider more kind of high art, in this case, impressionist painting of a cathedral, and yet is it about rendering this cathedral precisely, or is it about the impression, the sensation of it, the play of light? It is not per se maybe technologically accurate, but it's about the way that viewing works, right? Both technically, but also aesthetically and creatively. What are you looking at? And I think that comes into play quite a bit with our work, and there are opportunities there when we're applying technology. So this is Nude Descending the Staircase by Duchamp. A woman descending a staircase, but not at all. Maybe the figure of a woman abstracted into planes, into shapes, into forms. So it's at once about a person, but it's also about abstraction. It's the idea of movement or the idea of a figure that's being transcribed into two-dimensional space, which doesn't feel that far to me from this Chuck Close painting, which is a portrait that is made up of, gosh, I want to say pixels, but not. It's painted. It's painted blobs of color that together synthesize an image. So it communicates both the portrait, but also the process. And I notice process, the way that its artworks are thought of and made and instantiated, is very important to many works. So that's, I think, going to be an angle today when we're programming, or when I'm showing you some methods, that the planning of that method is just as important, if not more, in some cases, than the work that comes out of it. So it's not always the specific instance, but maybe the process used to create that instance, which doesn't feel that far from this Golan Levin project, which is a face, but a face made of lines and splines that are rendered over time. So it feels impressionistic. It's not an accurate mapping of a face, but it is somehow falling within the realm of portraiture, which then leads us to some very specifically AI-generated work. In this case, a Mario Klingemann piece, where these faces are being instantiated from a system that has learned through training and through observing many faces on its own how to synthesize a face. And yet there's deliberate play here where these are two faces. The system is being corrupted, is being tinkered with, maybe is being tested what the bounds of the system are, which I think can be a very ripe area when we're dealing with technologies, is how far can we push them, or where are there accidents that come to be fruitful over time. And then another Klingemann piece, same idea, right? Training a system, a computer, to know how to make an image and then toying with the way that it presents that image. And a third piece of his as well, trained on bodies and flesh and portraiture, but making something that is a bit of a visual conundrum that maybe celebrates how the technology is brought into play with the piece. And this, I think this is the last of the artwork slides, Pinder van Armen. This is from a fellow who makes robots that paint and that use neural networks and machine learning to assess along the way, to observe and make some judgment about the piece. So it's not simply printing a piece of imagery, but building it and assessing and making decisions based upon that. So let's try to define artificial intelligence, or maybe let's just break down some of the bounds that we might feel if we're not technologists, or even if we are, that are artificial intelligence. In the case of artwork generation, I think it's easy to assume by AI we might mean something like machine learning or neural networks or some highly technical process that is a bit of a black box and can feel like presents many limits to how we could engage with it. But I think AI, in my mind, is about partnership, is about autonomous creation. So there's some intelligence, which is where, in my mind, I think of autonomy and maybe economy and the ability to rapidly iterate. There's a partner of technology in relationship with us. And I think when we put it that way, it opens up many ways of thinking about applying artificial intelligence to the creation of artwork or creative projects. Certainly generative systems that are more code-based, more algorithmic, and less black box, machine learning models are quite appropriate. And rules as a way to think about algorithms and to think about utilizing technology to make things, defining systems of rules that can help us kind of limit and constrain and guide the building of imagery or poems or sounds or dances or whatever it is that we're working in, that seems very fruitful. And of course, yes, machine learning and neural networks and things like inference are certainly fall in this domain. But I suppose my point here is to think wide and openly about how artificial intelligence can come to play in your work, and to not let you be limited by some presuppositions about what does and does not qualify if you have a compelling argument otherwise. So we're going to start in a moment looking at some code, and I'm going to be sharing my screen and showing a kind of introduction to ways that we can use a procedural system. In this case, we're going to be using P5.js, which is a JavaScript library and editor. It's a web-based implementation of this amazing processing visual programming language that came out of MIT, came out of the Computation and Aesthetics group, and has been a powerful tool in bridging computation and artists, and allowing artists and designers to be able to develop very kind of robust implementations of procedural work. And I'm going to be using the editor from P5.js. I should also note that the links I'm showing here, I'm going to have put up into the YouTube description. So following this talk, I'm going to be sharing all of these links. So what you're seeing me work on will be available to you absolutely in a way that you could make derivative works from it and build on this. So P5.js, I am currently in the editor of P5, and I am logged in. You need to make a login as yourself. Well, actually, you don't need to. You can start coding without having a login, but assuming you want to be able to save your work and be able to return to it, maybe share it, you do need to make a login. So this is tied to my Google account and I'm logged in and there's no charge. It's all kind of available freely. And what we're looking at is a little coding window here with some code that we'll step through. On the right-hand side of our screen, we have a preview window, which is going to show the work. So this is about visual creation, largely about visual creation from code into the preview window. And then at the very base here, we have something called the console that I'll just clear for now. We don't need to know that yet. We have a name of the sketch and we have a start or play, which sets the sketch, which is the term for an application or a piece of programmed code in P5.js, and we'll set it running. I should mention that all of these pieces I'm going to show are in a collection of mine that, again, I will be sharing. So all the sketches we're going to look at are going to be available to you to duplicate, to change, to work from, to copy, to paste. The beautiful thing with programming and code is that we can borrow heavily, we can make derivative applications, and there's a great community surrounding the sharing of content. Also, on the P5JS org website, there is a comprehensive reference to the language, to the methods that we're going to be using, as well as community and examples. It's a great place to learn coding. This is a highly supportive environment for learning visual programming. So let's look at what my code is going to show. On the left-hand side of my code, I have line numbers, so I can refer to very specific issues that come up in my code. And the very first line says function setup, and then open and close curly cues. This thing called setup happens one time. And by default, P5 is going to set up something called a canvas of a certain size. And the canvas is literally the canvas we're going to be drawing into or creating into. The measurements create canvas are in pixels. So create canvas 400 by 400 pixels. So it's going to make a small window that I'll be able to draw into. And then setup stops. Setup only runs one time. In line 6 and below, we have a function called draw. And draw is saying background 200. 200 is a grayscale color. If we think of 0 to 255, we have a range of colors. So this is going to make a certain background color. And I am going to put // which we'll call a comment. That is something that says to P5, ignore anything that has these two // And you can see it grays out the code. So the only code that's being executed and that we need to be concerned with in this first sketch is in color. Function, setup, open curly Q, create canvas 400, 400. Very important. Semicolon, syntax in programming is important. And then close curly Q. Function, draw, open curly Q, background 200, close curly Q. I'm going to click play to execute this, and we see I get this box, 400 pixels by 400 pixels in my preview. And background gave it this color. So let's change that number for background. What if I say 20 and play? Darker. And if I say 240 and I play, lighter. So background is simply filling in a certain color into that space. I'm going to uncomment my next line of code, which says line, literally draw a line from 0, 0, 200, 200. Let's go to reference and let's look. I'm going to switch over here and look at line. In fact, I'm going to Control F and find line just to show what a lovely reference they have for this language. So when I don't know what that 0, 0, 200, 200 means, it tells me it's going to draw a line from an X location, Y location to another X and Y. So I'm giving it coordinates in my 400 by 400 grid. I'm drawing from 0, 0 to 200, 200. And if I click play, oh, so 0, 0 is the upper left-hand corner and 200, 200 is the very center of my screen. And draw, even though it looks static, draw is constantly drawing by default. So it keeps drawing this thing over and over again, over and over, over and over. If I were to change this to, let's say, 166 and play, well, Now I'm going 100 across and 66 down. So far, so good. We've made a line. Is it art? I don't think we're there in the realm yet. We don't have the kind of process and intention in mind, but we're starting to see what we can make. Let me uncomment my next line of code, line number 9, which says, now line from 0, 0, same corner, to random 200, random 200. So watch what happens. Every time draw executes, it's saying background 200. It's wiping my background clean and putting in this color. It's drawing a line from 0, 0 to 166, which is that static line that we see here. And then it's drawing a line from 0, 0 to a certain random location. And it looks like this animated random drawing. Interesting. And if I were to comment out my background, now there's no gray and the screen doesn't refresh. So it's actually drawing and accumulating, not refreshing and clearing the screen. So it's creating this pattern that is changing over time. And maybe it's adding visual complexity and some sense of filling in the bounds of my random numbers there, or my random locations. That's intriguing. Let me comment out my lines and uncomment these. So instead of drawing a line, we're going to fill in the background color, and then we're going to set something called a text size. It's going to be the size of the text. We're going to make text for a word of a certain color, and another word, and another word. And if I click play, well, there I can see how the colors, which is the fill. So fill is what fill color is going to be inside the letter forms of that word, has a certain RGB value, and it writes words in specific locations, X of 10, Y of 30, X of 10, Y of 60. So I have these 3 descending words. So I can handle words as well as lines in processing, or in P5, excuse me. So let's up the ante here a little bit, and I'm going to uncomment line 18, and this says draw line, lowercase d, uppercase L. We'd call this camel case often, in that it has like humps. So it's lowercase d, and then the L is expressed uppercase so that we can cognitively read the terms and unpack what we've written here. And it says draw line, and it's handing it a value of 10. Now what I've done on line 24 is I've made a function called draw line, and it takes in a certain thing that I'm calling number, or num, short for number. And then within draw line, it's saying, okay, so this is something called a for loop. For every instance of number, start with 0 and then go run this one time and then increment again and run it another time. It's going to draw a line, random start point, random end point. So it's going to say I is set to 0 when it first runs. It's going to make a random line, and then it is going to I++, which means add 1. So I goes from 0 to 1, and it goes through this again, and it keeps going through it until I is, as long as I is less than this number. So essentially, it's going to draw 10 random lines. Let's click play. That's interesting. It's drawing random lines. It's beginning to maybe feel a little bit like a silhouette drawing, albeit a tiny little one on screen that's moving really quickly, but I've begun to algorithmically tell it to make something, and to make something in a certain way. And granted, we're just scratching the surface, but if I put other logic in and express certain values or make rules that are slightly more nuanced than this, I can begin to instantiate some very kind of distinct works. I'm going to go back to my setup, and I'm going to turn on something called no loop. And this is going to stop that constant looping that happens by default. Because while that may be appropriate for us, and we may enjoy seeing animation, the ultimate deliverable will likely, it has to in our case, be an image. So it's useful to know that we can pause this and set this to be a single instance of the loop of the draw function. And I'm going to comment out my text. So let's see what happens if that is one instance of my 10 random lines. And if I play again, it's another. And if I play again, it's another. And this reminds me of something that me and Nick expressed in our last learning experience, which was trying things out and looking and seeing what happens and judging based on what you're getting, that you don't always know what you want to end up with, but that along the way, if you're trying out and you're attentive, you can begin to edit down and think maybe about, why does whatever I'm looking at, whether it's lines or a picture or a synthesized image, why is this resonating with me? Why might this be headed in the direction where I would want to explore further? Or maybe why not? And what can I do to pivot away from that? Let's say, what if I increase this number to 100? Draw line 100. It should make 100 random lines. Interesting. So it has some flexibility. 200. I think we get the idea here. The next method, I'm going to comment out my draw line. A method here called draw polyline. So lowercase d, capital P, capital L, and again, it's being handed a number. And if I look at where I defined draw polyline, it's a little bit more complicated. It is defining a starting point when it's first called. So I'm going to call it with the number 10, and it first figures out a random width and height for my start value. And then here's another for loop for as many segments as I gave it, and it sets an end value, draws a line, and then says, well, the end of that last line, make that the start. So the next line is going to draw from the end. So it's going to make, instead of random lines, it's going to make linked random lines, which I would call a polyline. So let's play that. Oh, interesting. So now maybe it's making a form rather than just random lines. It's beginning to question what shape it is. There is no logic intentionally in this sketch that is telling it to draw a certain thing, but it is drawing a line that suggests enclosure somehow within this. And of course, we can make a method called draw flower or draw some other rule-based system. And the logic could get far more sophisticated or more intentional. Maybe we don't need to say sophisticated, but more intentional in here. And we could begin to instantiate other types of visual work. I'm just going to set myself back to the very beginning, and I'm going to save this and move on to my next sketch, because I think we've kind of gotten the basics of this. And I'm going to look at my second sketch. Second sketch says line 1, let len equal 100. In JavaScript, this is how we can instantiate a variable, some place to store something. So I have this thing called len, short for length, and that is by default set to 100. My setup that runs one time, remember, creates a canvas. Oh, it's bigger now, 1024 by 1024. If we're submitting to our competition, the call for 2022 says we need to provide a 496 by 496 pixel file. Now, that doesn't mean that we have to save out that size, because maybe we're just making a piece that is part of a larger process. Maybe we're making visual content that we're going to arrange somewhere else, but the end product needs to be 4,096 pixels. So that's pretty large. We're getting there from our 400 to 400. So let's see what we get with 1024. We are setting this to no loop, so it's going to only run this draw method here one time. In fact, look, the draw method has been removed. We're actually not using draw whatsoever. What we are doing is we have a function called draw polyline, which looks like it's the same function that I had before. I just copied and pasted from my old code. And two new functions, one called mouse pressed. Literally, when the mouse is pressed, do whatever is inside this function, which says set the background to 200. So it's going to wipe the background with a clean color, and then it is going to run draw polyline with len of 100. So it's going to make a 100 segment polyline. My next function says key pressed. Whenever a key on my keyboard is pressed, do something. If the key code is escape, meaning if I press the escape key, then save my canvas. Interesting. It looks like this is going to take our drawing and get it out of P5 and actually get it into a file, which is really helpful for what we need to do for our competition. Otherwise, else, it's going to send to this place down here called the console, incorrect key pressed. So let's see what happens. I click play. Nothing happens. There's no draw method. It's not doing anything until mouse pressed or key pressed. Now in P5, we do have to focus our scene on this preview pane. So I'm going to click on that preview pane. And when I click, oh, interesting. Every time that I click, it runs background 200. So it wipes what was there and it draws a new polyline of Len. Now I can't see the whole canvas because I'm at 1024. So I need to scroll here. This is a challenge. But what's important is I don't have to draw into that tiny window. Sometimes if we're using web-based tools, we think, oh, I'm limited to some little thing. And that brings me back to a statement that Bill Fick had made in our last learning experience about size and scale and appreciating form and getting beyond the small thumbnail that we're working with in some of our digital programs. And this is allowing me to do that. So let's see what happens if mouse pressed is iterating me through different random polyline forms. Key pressed, escape should save it. So I'm going to press not escape. I'm going to press H on my keyboard. And it tells me incorrect key pressed. Do I need that? Not really, but I just wanted to show how we can send things out to the console, which can be helpful for us to know where we are in the program. And if I tap escape, my canvas JPEG, fantastic. It is saving it. I could save my file. I could open it up in my photos. And now I have a 1024 image. I could accumulate many of those. I could, if I wanted a 4096 image, I could simply increase this number to 4096. It'll be very hard to see on my screen, but I will be able to generate, let's say 4096 and 600 if I click play and click and escape and open with photos. I now have, wow, very different scale and complexity. Look what happens when we go into a big file like 4096. It's a different work. I won't say better or worse, but boy, the overlaps become more meaningful. And maybe even a simple drawing algorithm could create some really intriguing visual work. So that's our second sketch. I'm just going to set these back to 1024, and then we'll move on to our next sketch. And set my length back to 100. And let's open third sketch, image display. This is very short. It says let img, and then I have a comment here, declare a variable image. Hopefully I'll add more comments to this code to make it a little more self-explanatory. I'm making a variable called canvas height and canvas width, which will be useful later. Up until now, we could just type in these numbers, but in some other sketches, I'm going to want to do more with these numbers here. And then the setup creates a canvas of, let's say 500 pixels. It's going to load an image where? Where's the loading this image from? If I click this arrow to the left of my sketch, it shows me that under the hood of how P5 is working is actually, there is an HTML file, which is loading in my JavaScript. So if you've done any web development, this should look very, I imagine, comfortable or familiar to you. So little HTML file, it is placing the sketch in the body. It has a style sheet, and the sketch.js is what we're looking at by default. That's the work that we're editing. However, notice I have here a folder with something called David Bowie, which is a spoiler alert picture of David Bowie. I could create folders, I can upload files, create flat files. If I go back to my sketch.js, maybe now it makes sense that it's loading a relative path of the folder called images, David Bowie, JPEG. Of course, the capitalization and syntax in all of what we're doing is incredibly important. So if I type David Bowie differently, it wouldn't be able to find that image. If I used my capitalization differently, it wouldn't be able to find it. So this is important that I am able to be very clear and consistent with my coding. And then I have a function called keyPressed. Again, any key. In this case, it's not asking for a particular key. It is going to do something called image 00 with height. Essentially, take that thing you loaded, David Bowie, and place it at 00 and make it the width and the height. So let's click play and key pressed. There we go. Picture of David Bowie stretched out to 500 by 500. So I've taken a little liberty. It was more of a narrow image. This was for a demonstration. I wouldn't want to back into that without some intention, thinking about the size of my and format and aspect ratio of my image. But this means we can start to do things with image files if we want. So let's move on to our next sketch, which is going to do more with images. If we were at sketch third, let's go to sketch fourth. Ooh, this one's bigger. It's called pixel cycling. Again, we have images, David Bowie. I just duplicated my old sketch to start with. It is making an image, a canvas of a certain size, and it has some new variables. Pixel step, pixel value, new pixel value, pixel threshold. We'll see where these come up in the code as we go through the project. Under my setup, it's making a canvas, place to draw. It is preparing my David Bowie image to be loaded. And that's because when you load in a file, it can take some time to get it instantiated into memory. So we don't want to try to load it and write it immediately, because then those things often aren't able to be sequenced. One isn't ready. The image isn't ready to be loaded. So this is preloading it, if you will. I have a function called keyPressed that is going to place the image and then also not run any of these because these are in comments, but it's going to run something called cycle. And if we look at line 23, I have a function called cycle, and it says for loop for every pixel in the width of this canvas. So it's going to check this width of the canvas, but notice it is not incrementing I++, which we've seen before. It's not checking every single pixel, and that's because the way I'm doing this through coding is not terribly elegant and tends to be slow, especially for a real-time demo. It would take a long time to execute. So I am instead using this thing called pixel step that I defined up here, 50, to allow me to say, I want to check every 50th pixel. So take 1/50th of the time to cycle through this. So it checks for every width. And then for each one of those widths, it checks for height using that same pixel step. And then it gets, which is get the value of that picture that's loaded, that image. Get that pixel value and print it to the console. So let's play and key press anything. Oh, I have to click into my preview area to focus the image or focus the sketch. So let's see what happens. I get David Bowie and I get all of these pixel values here. So each of these is 1 pixel, and it's giving me the red, green, blue, and something called alpha or transparency. So this pixel right here has a red of 174, a green of 124, a blue of 91, and an alpha or transparency of 255. So it's totally present in my sketch. Useful to see that we can get those pixel values. This cycle function is more for peace of mind, to explain how I can understand that get function and that it gives me pixel values that I can work with. So I'm going to comment out cycle and instead uncomment cycle to black, which looks pretty similar. It is testing again this image in steps that are big, 50 pixel steps. And then what's happening is it is actually setting the value of pixels to a different color. So let's play and see what we get. So I want to tap a key. All right, I get it. It is looking in these 50 pixel blocks of David Bowie. And for each one of them, it looks like it's replacing a certain value, not the whole block with black, but like a quarter of it. And if you'll see here, what's happening is it's saying for every 50 pixel step, but divided by 2 for 25 pixels, it is going to set those pixels to essentially black and then update it. So I'm beginning to see that I can change that image. I can read it. I can get the pixel values. They're in red, green, blue. I can do something more with that with my algorithmic knowledge. I could separate them out and make some decision based on those colors. For now, I'm just overriding those colors. Let me turn on cycle invert. Another function. Let's look down here and see what that function does. It says, I'm just going to open this up so we can see a little better. And by the way, if in P5 I ever get kind of some strange indentation, which can make it hard to read, there's a beautiful command called tidy code that's going to go through and indent properly so I can read the hierarchy of my code. So cycle invert, again, steps through that whole image at that pixel step. It gets a value and holds it. And then it's making something called a new pixel value. Think of this as a new color. And it's making 255 minus the value. So it's like inverting it in 255. 0 to 255 is my typical 8-bit color space. So it is pushing it kind of into the negative realm of that color space. And then it is setting each of those blocks to that pixel value. The best way to see this might be to play it and to tap a key on our keyboard. Took a moment to run. And it's interesting now, it's no longer David Bowie, but the form is kind of there and the colors have been like flipped. So I've made maybe a filter that has pixelized based on this 50 pixel block. And, it's reminiscent of the image that I started with, but yet not. So let's change our pixel step value to, let's do 20. This should be smaller blocks. Let me run, tap a key on my keyboard. Took a little bit longer. It took like 4 seconds to run this time because the steps that it's going through on the image are smaller. But yeah, now I can begin to see a little bit more easily where David Bowie is. So that pixel step value is how big a chunk of pixels do I want to deal with at one time. So now I'm beginning to not just replay an image, but use some sort of content as a starting point and make some changes based on that content. So the last part of this sketch, let's look at, cycle clip value. Looks somewhat similar to begin with. It's checking through every pixel step, and then it is holding some pixel values, and it is if the average of red, green, and blue is less than a threshold that I set, it's going to set the color to 1, else it's going to set it to, it's going to set the color to 5. Otherwise, it's going to set it to 250. So it's saying, depending upon the brightness, make every chunk of this image either dark or light. So it's clipping it. It's going to make an extreme high contrast image. And I think we ought to set this pixel step back to 50 so it runs quickly for now. Play, click key on my keyboard. Wow, I don't know if I see David Bowie, but I definitely see light and dark operating in this image. And I'm going to lower this to 40. Click play. Interesting. I'm going to lower it to 30. Click play. You can see the benefit of having these variables up at the head of my code is that I don't need to get way down into my function and make some change. If I know or I get the sense that I want to change something moving forward, I can do that up here. And I'm just going to set this to 10, and it's going to take a little bit longer to run. Let's see what we get. And there's my pixel threshold. So, there we go. I definitely see David in that I'm going to set this to 20 and just change my pixel threshold a little bit, maybe 188. And maybe let's put David Bowie into a larger frame, 800 by 800. So click play, tap a key on my keyboard. So it's in the background, it's stretching him out, fitting him into this new frame of 800 by 800, going through in steps of 20. So 1/20th, there we go. And that's what I'm getting at the end of the day. It's not a dramatic difference, but I hope you can begin to see that by being able to access the pixel values, we could do all sorts of interesting things far beyond what I've been doing here in this sketch. So let's keep moving now that we've seen that we can load an image in. And let's look at if our fourth sketch was pixel cycling. Let's look at our fifth sketch, image replace. It's making a 600 by 600 canvas. All the stuff looks the same, except I have something new called dot size, a new variable that must be used in a function lower down in my code. The setup makes a canvas, loads an image, and then does something fantastic, makes another canvas that I can't see. So David's going to be there, and I have the same size as David, something else that I can draw into. And the beauty is I can not only overwrite David, but I can make something new, and then eventually I'm going to put it on screen. If key is pressed, let's make it do something called cycle. It's going to put the image on screen and then cycle. It says console log cycle function running. So that's going to just tell me where I am in my code. It's going to let me understand that that piece of code is executing. So it gives me some peace of mind in case I'm trying to track down issues. It's going to go to that other canvas and set its background to a color. Everything that I have PG, it's not going to be drawing on screen. It's drawing into this separate space, like a buffer, we might call it, off screen. And it is going to look at the values of David Bowie. It's going to get those values. And then in that buffer, it is making a stroke, which is a color for a line, a weight, which is 5, so a thick line. And it is going to draw from random points. This feels like our first sketch. It's going to draw from a random place to the current location. And the very last bit of cycle is it copies that buffer that has been drawing these lines into, it copies it back onto screen. So let's see if I click play and I click, always I have to click into preview to focus P5. And then I tap a key on my keyboard. It's loading in David Bowie. It is sampling and figuring out what color is this pixel. And then it draws a line. So this is in some ways the colors of David Bowie, the colors of that picture, but then turned into lines that originate in the pixel value, but then go to some other place. So it's kind of procedurally abstracted and contorted and distorted this piece of information, this piece of visual media that I started with. And I was really taking advantage of the partnership of technology. Like I could paint this, but that would take a huge amount of time. I could iterate through many of these very quickly and iterate through them at a small scale like I'm looking at, but we've seen that we can change the canvas width and height. So I could quickly update this to run at a really big file size and save it out. And I just would not want to be running a real-time demo because it might take 3 minutes to run, but really quite powerful tools. So let's look at our other functions here. If that was cycle, I have something here called cycle dots. And console log, it's going to tell me what is running. It goes through and checks all these pixel values. And then instead of drawing a line, it is making a circle. In fact, let's just do this. It's going to draw a circle of a certain size from dot size and put it on screen. So I just clicked play and tapped, wow. In this buffer, it had gone through testing every 50th pixel, figured out the color, drew a circle against a background color, and then copies it back. And if I were to change that dot size, I could maybe change it up here. Let's make those larger. 30. Play. Click. Key press. Running. Intriguing. What used to be small dots are now large dots. I could make different sizes of dots. In fact, let's do that. Let's go to cycle dots and now draw them with a certain amount of randomness. So it's going to use that size. Let me set it back to 15. It's going to say every dot should be 15 plus random 10. So could be 0, could be 10, could be any number in between. So every dot's going to get a different size, a random size. Let's see what we get. So I've begun to make a filter that pixelates. It reminds me of dot screens. And from our last learning experience, Bill Fick was talking about Liechtenstein, the painter, and dot screens and the printing process. And now we've made a technological version of assessing an image against its values and making a screen of sorts. And I could extend this logic in many ways, I'm sure. I could make it with lines. I could make it with all sorts of patterns. This, now that I'm uncommenting, is going to make a somewhat random location of the circle and a random size. So I think it's going to start to scatter those ever more. Yeah, so you get the idea. We're just extending through a single line of code, changing the way that this general process works. And the last piece to show here is cycle.screen. And cycle.screen, this is a little complicated, but it is taking the average value of the pixel and making the size based on that. So instead of being random, it is querying what's essentially the brightness of the pixel, and it's going to make the dot exactly what we're seeing here. So where there is no lightness in the image, it makes really big dots. And where there is lightness, it makes very tiny dots. And so we begin to get a sense of what our content was. Now, this sketch has all been based on David Bowie, right? Very figural, very specific. And by no means do we have to start with a picture of someone or a picture of something. It could be a texture. It could be a space. It comes back to that question of process and what we're trying to get out of our project, what we're trying to explore in any given space. So let's look at, very briefly, because I'm keeping my eye on the time and we need to get through a number of other topics. There are such things as libraries or pieces of code that other people have written and contributed to P5. And there are many of them located here or cataloged here in this libraries page. And I want to show you just a teaser of a few of those libraries and some simple implementations of them. Oops. Save. There is a library called ASCII Art, which I've downloaded as per the instructions and placed into my files here. And if I play this, it takes an input image and the library maps from brightness value to ASCII code for the amount of brightness in, or the amount of pixel value in a character. So we've seen this before, right? This is a way of drawing. It really originates with early representations through dot matrix printers and such of graphics, and this library emulates that. And there may be some interesting opportunities to work there. There are a number of variables in here that if we spent some time looking, we could make some changes to. For instance, I can change the size of the text. Comment this out. If I make the text size from a value of 8 to a value of 22, we're getting the same image, which is taking a graphic image that was uploaded, and as this library is analyzing it, much like our dots were being analyzed, but it's doing it on its own in a whole bunch of code that was written by someone else. And now we start to get this maybe somewhat a conundrum of language and image. It's a little simple, but there seems to be some opportunity in that. Let's look at another library called Risograph. This was I think mentioned by Kelsey Broad in our last learning experience. She and Bill Fick are co-teaching a class on printmaking and this language, P5JS, this semester. So using technology to make the plates and graphics that will be used for the analog printing process. What's happening in this file, I have a JavaScript library loaded into my project that I downloaded from the authors of this library. It is loading in an image that I put up there of a tree, and it is going to make a filter of that. And if I look way down here at key released, it's going to use dithering, or the ways that pixels together synthesize certain values. There are different methods that can be used to instantiate those values. And if I press key 1, 2, 3, 4, or really if I release key 1, 2, 3, 4, it's going to run me through those. So let's see. If I tap 1, oops, key released 2, 1, 2, you can maybe see that it's changing a little bit. And then as my mouse is moving, it's picking, maybe it's like the central value of or it's the X and Y relates to lightness and darkness. And if I do 4, it's a different algorithm. And I think the way it works, if I read my code line 29, function mouse clicked, export reso. So click, yeah, it's exporting. So the library has a function much like our earlier save function, where it's giving me a file. So I can use this to investigate in a very real-time way the way that I can kind of use this library. And we're just kind of skimming the surface of what these libraries can do. So there's much more to be discovered if they seem of interest to you. The last one I'll show is a language-based library called Rita, that this one is going to make some random rhymes. So this is based on word analysis, language analysis, and it is going to take a word and find some rhyming words and play and kind of draw those into the scene. So every few seconds, it's picking a new word and then searching for some rhymes and throwing those into the scene, and it's cycling through and updating. And that's intriguing. That, has shifted us out of this pure visual domain into the domain of language. And the last that I'll show is it can also ingest text and then create, infer what new text would be based on existing text. So it can look at word relationships. And in this case, it is writing a new piece of text. And it is, I think, slowly changing that, swapping out words where it is making some supposition based on the ingested text that it read and coming up with something new that is in the method of writing in what it ingested. So that is interesting for kind of language association. So let's go back to our slideshow. So we've looked at that editor. I'm going to share my collection of all of those sketches. If you're interested, you'll be able to duplicate them, tinker with them, make changes to them. We looked at the libraries for P5, the Risograph library very briefly, the Rita library. So let's look at another method for employing AI to make images. And there's a method, a type of neural network machine learning process called pix-to-pix that is really intriguing for synthesizing new images. And essentially it's learning associations between pairs of images. This is a figure from the original paper that was published on it. On the left-hand side, we see one side of the pair. On the right-hand side, we see the other. And the idea here is it trains to recognize the color that is being used to label semantically certain parts of content. In this case, light blue where there's every window, green where there's every maybe balustrade, orange where there are balconies or trim, and blue, dark blue where there's just general facade. So it's learning based on the codification of the image on the right. So you feed many, many, many of these images where a facade has been labeled, and as it takes time to process and learn and kind of become aware of many of these pairs, you can begin to feed it other labels. So this creates a neural network that if you give it those colors, it is going to presuppose and infer what pixel values should result from those. And it is essentially then a facade drawing tool, which could be used to make very legitimate facades, or could be perhaps exploited and hijacked and used in a way that wasn't intended at all. It might be intriguing to see what comes out of it if you're feeding it the wrong information, if you will. Another one of the examples from the original paper is handbags that were paired with their line drawings or their edges. So the handbags were taken from internet imagery from online sales. The line drawings were created parametrically by running a script that essentially finds edges. If you've ever done that in Photoshop, essentially that's what it's doing. And this begins to learn how to draw or instantiate a synthetic image of a handbag based on a drawing input. Again, we could give it the input it's expecting, or we could give it an input that's very different than what it's expecting. And this is an instantiation of it through a web page where those models have been loaded. And let's look at, so here's our facade, and let's just clear this. And if I draw in a window, a window, and a window, I draw in a door down here, and maybe a piece of trim across here and here. And then I'm going to process. This model that has been trained on many of these pairs is going to take that input and try to figure out what's the resulting facade that is not part of the original set. How can it deliver a facade to you? So on the right, we have a facade that these are not aligned, these windows, that door seems quite large, and yet it's incredibly compelling because it is synthesizing based on photographic evidence from the world around us. And these models have already been trained. I'm not suggesting yet that we train our own, but they're available in implementations to use. They're made freely available to originally to showcase the methods through papers and research and such, but could be really an intriguing opportunity to hijack those. This is the edges to shoe. So not edges to handbag, but let's draw a shoe. Maybe draw something like that and process it. So it thinks that's my shoe. Let me try to draw a little bit of a better shoe. Not that our goal is always to make things that work, but if we know what it's looking for, might be expecting a shoe that is somehow a bit more like that. Interesting. And if I were to give it something that was totally not like a shoe, intriguing. I'm not sure what we're getting out of this, but working with a technology that thinks it knows how to represent one type of content and using it in another way seems absolutely intriguing. And here's the handbag. Let's go up and look at this cat. This is an interesting one. If I were to draw a face of a cat with 2 ears, this has been trained on pictures of cats and the line drawings that can be resulted from those. So essentially it becomes a cat sketching mechanism. Let me add some eyes and a nose, and it becomes this very compelling, maybe disturbing, maybe comedic, but intriguing way of working in partnership where maybe neither side knows exactly what's going to come out of this. And some of this could skew into the cliche and problematic or pointless, but there's certainly an opportunity here in the idea of hijacking and using a system that has been trained on these pairs. There's a link that I won't follow to the original paper and some of the content, which is intriguing. You can look at that on your own time. I next wanted to talk about something called a GAN, which is a generative adversarial network. And this is a neural network that is also used to synthesize images, to make new images that aren't something it's ever seen before. And yet it is trained on large numbers of data. So if we look at this slide, There are two components to a GAN. One is a generator that learns over time how to make a certain type of image. In this case, this is a handwritten numeral generator. It takes in as a starting point random noise, and initially it will make random noise, and it will feed it to another opposing entity called the discriminator that is trying to figure out, based on all of the data that it knows, all the images you feed it, is what it's seeing coming out of the generator, is it real or fake? And they both start out with being very, very kind of poor performers. And over time, if they're weighted appropriately, which is when kind of deep knowledge of AI is comes to bear, if they're weighted so they learn together at about the same pace, the generator learns how to take total randomness and fit out images that are of the type of what the discriminator has been looking at. And the discriminator gets very good at saying, this is not real enough image, or it is real enough. And based on that, they train together over time. And a way that we can do that, let's look at an example that I made of a series of leaf images. I'm just going to bring over the folder. This is a very small data set that I put together. And what's important about it is if we're trying to make a system, again, that can learn how to draw something like a leaf, we want leaves in our training data, right? And we want the leaves, in my case, I wanted the leaves to be oriented in a certain way so that this system would learn how to draw an upright leaf, stem to the bottom for the most part, and against a white background. So I'm trying to simplify the data. The number of images here is laughably small, like 30, but I guess I say that because in relation to robust, proprietary systems that are training on tens of thousands, it's laughable. But maybe as a creative artist, it's actually intriguing to see what you get if you have such a small data set, to see where those bounds are, to try to break the system or just see what occurs, because we don't have as much invested in making, per se, the most absolutely real leaf. Maybe we do, but I didn't in this case. I wanted to just make a GAN that could draw leaves. So I'm using, in this case, a new platform called Playform, which is a web-based AI model hosting platform. So we've split from P5. We are still in the web domain. We are in a platform that is free to use, but if you want to train, you pretty quickly need to feed it some fee to be able to manifest these. And if I look here at my training, what I've done is I've loaded in those 30 images, and Playform built on a cloud-hosted model a little GAN for me, a little adversarial network to generate images. And this slider at the bottom is how it documented the learning. So it saved out images along the way. And we can see in the beginning, these are random noisy images, and it's trying to make something, but it does not know yet what to make. And as I move forward, each of these are several steps in the process. Eventually, it starts to learn that there's a green shape in the middle and a lighter shape around the outside, and that's because I had been very consistent with that in my leaf images, and begins to make images that are more and more leaf-like. And these are synthesized images. It's kind of learned how to make leaves. It is not perfect yet in how it's making leaves, but I can begin to see stems. I can begin to see openings. I can realize that in my training data, some of these leaves had cuts in them. Some of them were solid. So it's trying to figure out how can it make something that's like that. And I only trained it to a certain stage. I could have trained it maybe for 100 hours. This was, I think, an hour or two's worth of time on the website in the cloud training. And what I get are these sorts of images, which, it is not a leaf, but it is now a network, a model of the every leaf, or trying to make a leaf. And I appreciate in this some work between me and the system of I curated images, and it's trying to understand what we mean by a leaf and how to represent it. And again, while it's not a perfect manifestation of a leaf, there's something very powerful in the number of attempts that I'm seeing and the way it's trying to synthesize a leaf. And maybe if I took it further, it would be compelling in a different way by showing actual leaves. In this case, I did something that Playform, I think, calls morphing, where I fed it leaves for the shape. So it learns very quickly how to make the shape of those leaves. And I paired that with an influence from a totally different set of images that were about um, storms. So I'm synthesizing leaf for shapes and contours. So this model is learning how to make the shape of a leaf, but then it's going to try to make some of the detail of the storm. And it's a bit of a conundrum. And you can see if I slide back and forth, I'm going to go from more leaf shape to the influence of this other set of data. And then it eventually is trying to make something that really isn't coming into focus, but is a type of image that I wouldn't make myself. And this is something that I couldn't synthesize myself, really. I mean, I could try to collage these together, but this is something very different. This is forming a system that can build these images. Another thing that Playform can do is, let's see if we look at these sketches. Let's see if this looks at all similar. So there are styles, and this is a landscape sketcher. So I am going to choose a Baroque style and sketch a landscape. Well, I'm actually going to upload to replace the background sketch, and I'm going to upload with, I made a line drawing from a photograph of a city. So this is a line drawing of a photograph of Vienna, and this is a neural network that has learned about Baroque cities by looking at both the color image and the sketch line drawing, right? It starts to feel like Pix2Pix because it's an implementation of that. And if I generate, it's going to take some time. It's working in the cloud. It tells me it's generating. And this is what I get. This is the sketch that I fed it, which happened to come from a photograph, but could be something I drew, could be something that was meant to be like a city or meant to be very different than a city. And it is giving me a variety of options to pick from. And then I can download these, I can upscale these, I can make more based on them. It's a very deep system. If I were to replace the background with something totally not city-like, let's say a little piece of a Sol LeWitt line drawing and generate, I'm not really working with the system here because it wants to draw a landscape, and I'm giving it just vertical lines, which is nothing like a landscape, but as a way of generating and finding new ways of thinking. This is intriguing. I can see the colors coming from certain paintings with the texture coming from this line drawing, and it is quite literally implementations of the Pix2Pix style. So this, we could spend more time in here, but I think the point is to show that Playform as a platform is a very interesting creative endeavor where you can take some of these algorithms and like Pix2Pix and have a little bit more detail brought to bear on them. The last thing I want to talk about is style transfer, which we've already seen a little bit in Playform, and it's the form and content of a certain class of images being separate from the texture and pattern. And it sadly quickly became very cliche, where these are images from the original paper. And Starry Night from Van Gogh was analyzed for texture and pattern and then projected onto the content of another image, or which the Scream was ingested and understood for texture and pattern and presented onto, again, that other image. So it became this cliche way of taking famous artwork, which was made by someone else a long time ago for another reason, and like applying it. And it's problematic because these are not Van Gogh images. This is, what is original here? And I think that's what we would need to think about. But there are opportunities with this process, absolutely. I'm going to bypass this slide that talks about separating form from texture. And you can do this in Playform, but I want to show you kind of final step here is something called Colab from Google. And What Colab is, and I will share the link to this, it's a third system for today, right? We looked at P5, we looked at Playform, we are looking at Colab, and Colab is running a language called Python. It is running something we might call a Jupyter notebook, but hosted up in the cloud. What it allows you to do is connect to a a virtual machine in the cloud in a data environment that has a GPU or a graphical processing unit that can make a lot of these decisions and really intense operations. So through our web browser, we can connect to a very powerful machine for free, for a short period of time. And if you pay a small monthly fee, you can kind of get a more powerful GPU and more time kind of on the system. But to get to the heart of the matter here, this notebook has text that explains a little bit what we're doing, style transfer, set up our runtime. We can read this when we have more time on our own. And then it has blocks of code. And maybe these look a little bit like our P5 blocks of code. They're written in Python. And what's great is I can click on this arrow to run them. So it runs little pieces of code one at a time. And it's in a virtual machine, and it's all the variables are available. And I am going to install this neural style library. So this library is a piece of code, really powerful piece of code that adapts the system that's already well documented and makes it expressive for us. And we're borrowing it and going to use it to make some images. I'm going to let that execute. You can see it's doing its little circle. It's executing. It took 22 seconds. It feeds this often overwhelming amount of code here, but that's just feedback from the system, and we don't need that. This is like a console. So as long as the system is working, I'm just going to X that. We get a directory of files. And what's really important here is when we stop our work in Google Colab, or we get booted off or disconnected, all of these disappear. So if we put files up, unlike P5, they won't be there in the future. So everything that I'm loading up here, I am going to kind of have on my own machine. And we see that there is an image input folder. These are the images for the form or content. There is a styles folder of the style. And then when I run the mechanism, it's going to give me an output folder. And so a basic style transfer, let's see, I am going to run something that is cliche. An image of a lion is the content, and the style is a famous artist Kandinsky painting. And we'll run this first to see maybe how many people might initially approach style transfer, though it's problematic. And then we'll look at some opportunities using maybe different types of content, different types of style images. And I've downloaded some images that I can show you that I kind of pre-formatted or pre-ran through the system. And we can see where there might be more creative opportunities to use the style transfer. We can see this is running in the background. It takes a little time to process. So if you're going to use it, just be prepared. You're going to wait sometimes, depending on your settings, which we'll go over in a moment, minute, 2 minutes, 10 minutes, 30 minutes, depending. So it has made now, if I go in here, image output, it's made a folder called image output, and then within that 100, which relates to something called iterations. Think of it as the baking time. So low numbers, generally under 1,000, 1,500, are not allowing the system to evolve as much knowledge, whereas higher numbers are going to allow it to evolve. And I'm going to play this cell. I just changed some of these numbers. It's going to play into the window below the input and the output images of what I just ran. So it shows me I started with a picture of a lion, not my picture. This comes with a library. This is some of the default examples, and a picture of a Kandinsky painting. And if the lion is the form and the Kandinsky is the style, when I give it a certain number of iterations, 100, this is what comes out. So it is collaging in a way the pattern of one into the shape of the other. However, it's problematic because I don't think we should be borrowing Kandinsky. There's nothing powerful in taking a historic painter's texture and borrowing it. There's nothing original in that. We're being influenced by an agreed upon painting. I'd rather use this more creatively. So what I'm going to show you are some outputs that I've already made. What is important about them is I often set this iterations higher. So if 100 just ran in a minute, some of these are set to 1,000, 2,000, and the other two variables, which are going to be in these lines below here in the notebook, are the maximum size, resolution, let's call it. So some of these, by default, these will be small depending on the images we feed in, but I could set it to be large. And then a style scale. So when we're looking at the texture, is it very small? Is it very large? How does it know how to map one to the other? So let me bring in a window of some examples that I ran. Here we go. I'll transfer examples. I was feeling rather portraity when I was doing this, so I don't mean to suggest that David Bowie needs to be anyone's content, or this picture that I grabbed of this figure needs to be anyone's content. But my starting point for content was I had a picture of David Bowie. I had this kind of portrait, photographic portrait. I had a picture of a tree and another tree. And then my textures were some microscopy of pollen. And then I thought also of, I used some smoke, some high contrasty smoke and splash. I used some cloud. What I was trying to think is, how do I escape this model of, oh, I take Kandinsky or some Van Gogh or what have you, but how can I make a more provocative form finding application of texture? So this is, pollen is the texture or the pattern that is then being filled in around the form of this figure. And that's intriguing. I don't know if it's quite where I would want it to end up, but this system has learned how to turn the pollen image into this pattern and apply it to this picture of this figure. Clearly, I would want a starting point of the figure picture that was very intentional. This was just something I picked. This is a smoke pattern for the texture against her figure. Let's just cycle through these. This is a tree and smoke. So the tree begins to get lost, but I was trying to see how could form of clouds and smoke be applied to another image. What happens when we look at one image through this kind of strange texture of another? Or what happens when I take that blue smoke and begin to outline procedurally this tree with that smoke? So this is style transfer, but I think much more interesting and greater in opportunity than the traditional application of arts. This is another smoke filter. The tree begins to totally get lost, right? It's this network of tubes that are somehow smoke colored and shaped like pieces of the tree. David Bowie is hard to escape, but intriguing how that little texture of smoke, I made it very contrasty in Photoshop to try to feed it in. And I think I made his image also very contrasty. And I did a number of iterations exploring different ways that this would work. This is pollen where the scale is not quite as small against that figure. And yeah, I just created a whole number of these looking for image pairings that were unconventional, looking for textures that were not coming from historic paintings, and thinking how could that be an opportunity to create kind of new works. And then most maybe importantly here is to note that I'm working in this collab and I'm running these things with images. I am, let's say, uploading. If I go to my styles, I can upload one of my images. It tells me this will get deleted, so make sure you keep it on your own machine. I can upload an image input here, let's say this tree. I can then change these to run if my content should be tree 2.jpg. And my style, I just uploaded unsplash contrast PNG. So my style is unsplash underscore contrast PNG. I run that, it is going to run. And when I get my output, I need to download that because all of this disappears. All the content other than what is delivered from the library when I install it disappears when I either close my browser or disconnect. So everything that I've been making along the way, if I were to spend an afternoon in here and be exploring different opportunities, I would want to download those files. And I think I just ran this. So let's look at image output. If I download, I would save, but I'm actually going to open in Photos. Interesting. That's what we just got. So I fed it this tree. I fed it this large scale version of smoke. And this is what I end up with from style transfer. I'm not going to dwell on this, but if I were to make the style scale smaller, let's say put in this 0.5, it would get much smaller smoke. And if I were to increase my max size, I'd get a much larger image. And if I were to increase my iterations, it would kind of bake it more and learn more. And that's very subjective. That would be a matter of looking at and assessing what the outcomes of this process is. So to get back to our presentation, I'm going to share these resources, some of which we've looked at today, some of which we haven't. We certainly spent some time in P5 looking at looking at algorithms and rules and drawing mechanisms and reading pixel values and changing them. ML5 is a machine learning library that works with P5. So it takes a lot of what we've been seeing in these kind of pix-to-pix systems and weaves it into P5. Paperspace, Runway, Playform, and Google Colab are all about cloud-hosted places that you can run AI processes. And Teachable Machine is a kind of Google's attempt to make some simple algorithms for AI very, very user-friendly. So again, I'll share these all in the YouTube description. And I think we are pretty much just out of time. So it's been a pleasure to power through all of this with you. And I hope it opened your eyes and made you think about some ways that you could engage computation and artificial intelligence really writ large in a collaborative way to make some content. And I'm looking forward to seeing the submissions that we get in our competition this year. So AI for Art competition, sponsored by Center for Computational Thinking. I believe the deadline is February 18th. So hope you all make some lovely submissions. Thank you so much.